In today's video, I have brought you a nice problem from Canadian Mathematics Olympiad edition 1977. Here is the following setup. F of x equals x squared plus x. If we have this equation, 4 times is multiplied by f of a equals f of b. Okay? So our goal, we are going to prove that this above equation has no solutions in positive integers. It may have a solution in real numbers, but is not in integer numbers. Okay? So before we get started, I would say thank you for your support for my channel. However, I need more support for this channel in order to continue providing more problems. I'm trying to work hard to bring you more and the best problems as I can. So by the way, if you would like to give the try to this problem, pre get to the solution, go ahead, pause this video when you will come back to see the full solution. Okay? Now let's get started. Suppose a and b are integer numbers such that this equation 4 is multiplied by f of a equals f of b has a solution. Okay, in integer numbers. When we are talking about integers, which means we are talking about arithmetic and number theory. So we are going through this way. At some points, we will find impossible to have a solution for this equation in integer numbers. Okay? I'm simply going to replace x with a and b, satisfying this equation. So I will have the following expression. So we'll have 4 times is multiplied by a squared plus a equals b squared plus b. Okay? Equivalent. By take for the left hand side of this equation, I'm going to take a out of these things. I will have 4 times is multiplied by a is multiplied by a plus number 1. For the right hand side of this equation, I'm going to take b out of these things as well, like this. Okay? So what's this one is telling us? This product is an even. Okay? So this one is an even. Why this one is an even? Because we have the product of consecutive integers. Okay? So if a is an odd, which means a plus 1 must be even. If we have a is an even, which means a plus 1 must be odd, even. So that means the product of this even and odd is going to give us even. Okay? I'm going to set this product on this form. A is multiplied by a plus number 1 equals to n. And notice here, we don't know which one is even, which one is odd. We know the product is even. Okay? So I'm going to insert this value of this product into this equation to see what's given us. Obviously, it's given us 8 is multiplied by n equals b is multiplied by b plus number 1, like this. Okay? So this one, by using the congruence definition, I'm going to reduce this one to mod 8. So this one equivalent, b is multiplied by b plus number 1 is equivalent to 0 mod 8, like this. Okay? It's telling us 8 divides b or 8 divides b plus number 1. Okay? This one is telling us 8 divides b or 8 divides b plus number 1. Okay? We are going through each one. We are going to work on both cases. So if 8 divides b equivalent, I'm going according to the divisibility statement, I will have b equals 8 times is multiplied by k, like this. Okay? What is so now I'm going to insert this value of 8 into the original equation to see what's given us. Okay? I will have 4 is multiplied by a squared is multiplied by 4a by distributing this, by following out this one. Of course, b will be replaced with 8k and b plus number 1 will be replaced with 8k plus number 1, like this. I'm simply going to divide both sides of this equation by number 4, and at the same time I'm going to move over this term to the left hand side of this equation. Okay? So this one is equivalent a squared plus a minus 2 times k is multiplied by 8k plus number 1 equals 0. Okay? I'm simply going to solve this equation for a, and by considering k as a constant. Okay? By calculating the discriminant of this one, which is delta, because we have a form quadratic binomial equation, delta will have 1 square, which is 1, minus 4 times is multiplied by minus 2k is multiplied by 8k plus number 1. By distributing this one, I will have delta equals 1 plus, which is 16. 16 is multiplied by 4, which is 64. 64 k squared plus 8k. Okay? By rearranging these terms, I will get 64 k squared plus 8k plus number 1. So in order to have a solution for this equation, we must have this term as a perfect square. Okay? We are going to prove it's impossible to have a perfect square here. Okay? This one implies we have this delta, which is this one, is strictly inferior than 8k plus number 1 quantity square. Okay? If I'm going to distribute this one, actually is giving us 64k squared as a first term. The second term is giving us 16k. The third term is giving us plus number 1, which means this one is strictly inferior than this one. At the same time, this one is bigger than 8k quantity square. Okay? Because this one will have k is strictly superior than 0. So since we have positive integers, since this delta, which is supposed to be a perfect square, is located between two consecutive, which means it's not a perfect square for all k as a positive integer. Okay? This one is a contradiction, which means what we have contradicted 8 not divided b. Since we have this contradiction, which means 8 not divides b, which means 8 divides b plus number 1. Okay? But if we found also 8 not divided b plus 1, which means both cases we have a contradiction, which means exactly the assumption that we have chosen before was not true, which means we have no solutions for this equation on integer numbers. Now I'm going to erase this board and move on to the next case. If 8 divides b plus number 1, okay? Previously we took the case when we have 8 divides b, it was impossible. Now we are going to check if 8 divides b plus number 1. So I'm almost doing the same job that I did before. So this one implies equivalent according to the divisibility statement, which means b plus number 1 equals 8 is multiplied by m, where is the m is a sum of positive integers. Okay? Which means I'm going to insert this found fact into the original equation. So I will have, as we have 4 is multiplied by a squared plus number 4 is multiplied by a. b plus 1 will be replaced with 8m, and b will be replaced with 8m minus number 1, like this. Okay? I'm going to do the same thing by dividing both sides by number 4 and moving over these terms to the left. I will get a squared plus a minus 2m is multiplied by 8m minus number 1 equals 0. So by calculating the discriminant of this one, which is delta, so we'll have 1 square, which is 1 minus 4 times is multiplied by minus 2m is multiplied by e to 8m minus number 1, like this. By distributing this one out, I will have delta equals 1 plus 64 m squared, this minus 4, which is 8m, minus this one, which is minus 8m. Okay? So by rearranging these terms, I will get 64m squared minus 8m plus number 1. Okay? I will have the same thing here. I will have 64m squared minus 8m plus number 1, which equals delta, which this one is supposed to be a perfect square to have a solution. So, but this one is strictly inferior than 8m quantity square. Okay? Because this one is always smaller than this one. Okay? if we have m as a positive integers, okay? Since we have m is a positive integers, it will be multiplied by negative. That means this term must be smaller than this term, okay? Which means 64m squared minus m will be smaller than 64m squared, okay? Array number one is not going to affect this inequality, so which means this one we want always hold this inequality. This one is smaller than this one. Also, I will have 8m minus 1 quantity squared. This term is smaller than this term. Because why? Because if I'm going to distribute this one, I will have 64m squared minus 16m. We have only minus 8m here, which as we have m as a positive integer, okay? Adding to plus number 1, which means the whole thing is strictly inferior than this one. We have this delta, which is supposed to be a perfect square, but is not a perfect square because it's located between two consecutive, which are 8m minus 1 and 8m as a squares on both sides. So which means it's impossible also to have a solution. It's a contradiction. So we have proven both cases 8 not divide b and 8 but not divide b plus 1 by considering EB as a solution for this equation. We found the contradiction in both cases, which means we have no solutions at all for this equation, okay? No solutions. So you guys, if you may check another method and let me know in the comment section below, okay? So also I would remind you, so from time to time I'm going to do some geometry problems and the calculus as well, okay? So if you have any question or suggestions, just put it in the comment section below. Thank you for watching. I will see you next video.